Welcome to section 14 of chapter Determinants. In the last class, we have studied how to find inverse of a matrix by using determinants. Today, we will use the same inverse for solving system of equations in two or more variables. That means we are applying matrices and determinants for solving system of equations. Before starting the topic, let me ask one question. What do you mean by consistent? A system is said to be consistent if its solution exists. Solution exists. A system is said to be inconsistent. Inconsistent if it does not have any solution. Does not have any solution. Okay, now I will explain how we can use this inverse for solving system of equations. For that, consider one system of equations: a1x plus b1y plus c1z equal to d1. And second equation, a2x plus b2y plus c2z is equal to d2. And third equation, a3x plus b3y plus c3z equal to d3. This one is a system of linear equations in three variables. Matrix equation corresponding to this system is matrix a1, b1, c1. That means I am writing coefficient of variables in first equations. And second row will be a2, b2, c2, and third row a3, b3, c3 into, so it's a 3 by 3 matrix, into a matrix with the variables x, y, z equal to right hand side again a matrix with the constants d1, d2, d3. Actually these two are equal. We can verify. If you multiply these two matrices, we will get a 3 by 1 matrix, because this is a 3 by 3 matrix and this one is 3 by 1 matrix. So when we multiply both matrices, we will get a 3 by 1 matrix. That means elements are a11, a21, a31. There will be only 3 elements in this form. So what about a11? How we can find a11? So first you have to multiply this row and the column. So we will get a1x plus b1y plus c1z, and you have to equate with d1 on right hand side. So we'll get same equation. First equation, for getting a to 1, you have to consider second row and you have to multiply with x, y, z. So we'll get a2x plus b2y plus c2z equal to, you have to equate with d2. a2x plus b2y plus c2z equal to d2 means second equation. Same way we'll get third equation also. That means matrix equation correspond to the system is this one. Okay, this is of the form A x equal to b, where A is this matrix and x equal to matrix containing variables and b means matrix using constants. Suppose A inverse exists. A inverse exists. A inverse exists if determinant of A not equal to 0. If determinant of A equal to 0, then A inverse does not exist. Suppose if A inverse exists, then we can multiply this equation with A inverse. So A inverse into AX is equal to A inverse into B you will get. What about A inverse into AX? We can use associative property. We will get A inverse into A into X is equal to A inverse into B. Now what about A inverse into A? A inverse into A is equal to I. We'll get I into X equal to A inverse into B. I into X is X because I into A is A. So I into X is X. X equal to A inverse in B. By using this equation, you can find solution of the given system of equations. That is the method. Actually, we need not write these two steps. We can write directly. Ax equal to b implies x equal to A inverse into b. But we have to check whether A inverse exists or not. That means you have to find determinant of A And if determinant of A not equal to 0, then only we can write x equal to A inverse into B. Otherwise, we have to use some other method. Okay. Now I will explain solving system of equation by using matrix method by using one example. Solve the system of equations by using matrix method. System is this one: 2x plus 5y equal to 1, 3x plus 2y equal to 7. So matrix equation corresponding to the system is 2, 5. That means variables of x and y. And second row elements are 3, 2. And here write variables in second matrix. Only two variables x, y equal to constants 1, 7. If you multiply these two matrices and if you equate with the right hand side, you will get same equation. You can check. Now this is of the form ax equal to b. First you have to find determinant of A. If determinant of A not equal to 0, then only inverse exists. Actually you have to use A inverse. So determinant of A is 4. Determinant of this matrix, that is 4 minus 15 is equal to minus 11, which is not equal to 0. Therefore A inverse exists and system is having unique solution x equal to A inverse into B. Actually we are multiplying both sides with A inverse. After that we are getting this answer x equal to A inverse in B. That step we need not write, we can write directly. Ax equal to B, then x equal to A inverse into B if determinant of A not equal to 0. System is having unique solution x equal to A inverse into B if determinant of A not equal to 0. Now we have to use A inverse for finding this value. How we can find A inverse? For finding A inverse we have one formula 1 by determinant of A into adjoint of A. So since it is a 2 by 2 matrix, we can find adjoint of A directly. What is adjoint of A? This you have to interchange diagonal elements, that is 2, 2, and you have to keep these two elements same but multiply with minus. So minus 5, minus 3. So we got adjoint of A and determinant of A equal to minus 11. These values we can substitute in this equation. So we get x equal to A inverse, that is 1 minus 1 by 11 minus 1 by 11 into adjoint 2 minus 5 minus 3 2 into B. What is B? Constant matrix. So 1 7. Okay. Now you have to multiply these two matrices. So you get x equal to minus 1 by 11 into product of these two matrices. 2 by 2 into 2 by 1 will get a 2 by 1 matrix. So first A11 will be first row and first column you have to multiply. We get 2 minus 35, that is minus 33 will get. Then minus 3 plus 14, minus 3 plus 14 equal to 11. Now we can multiply this matrix with this constant. X, capital X means it's a variable matrix containing variables x, y. Now right hand side you have to multiply minus 1 by 11 into minus 33, that is actually equal to 3. You get 3 here, then minus 1 by 11 into 11, answer equal to minus 7. Now we can equate both sides. We will get x equal to 3 and y equal to minus 1. In this way we can find solution of a system by using matrix method. Let us consider another question. Solve 2x minus 3y plus 3z equal to 8, 2x plus y minus z equal to 1, 4x minus 3y plus 2z equal to 4 by using matrix method. This is system consists of 3 variables. This type of question you can expect for 6 marks. Okay. So matrix equation correspond to the given system is 3 minus 2 3, right? 2 1 minus 1, 4 minus 3 2 into variables x, y, z equal to constants on right hand side 8 1 4. This is of the form, this equation is of the form a x equal to b, where a equal to this matrix, x equal to x, y, z, and b equal to the constants. Okay, now we are to find determinant of a. Okay, what is determinant of a? We can expand through first row. We'll get 3 into 2 minus 3. Okay, minus 1. Then plus 2 into 4 plus 4. That is 8. Then plus 3 into minus 6 minus 4. That is minus 10. Is equal to minus 3 plus 16 minus 30. That is minus 33 plus 16 is equal to minus 17. It is not equal to 0. That means A inverse exists. We can multiply this equation with A inverse. After that we will get x equal to, system is having unique solution, that is x equal to A inverse into B. Okay. Now you have to find A inverse. Here you have to find cofactors of all the elements because this is a 3 by 3 matrix. We have no direct formula for finding adjoint or A inverse. First we can find cofactors. What about A11? A11 is cofactor of 3. Minor of 3 is 2 minus 3 minus 1. Cofactor also minus 1. Then A12. Minor of minus 2 is 4 plus 4, 8. Cofactor equal to minus 8. Then A13. Minor of 3 is minus 6 minus 4 minus 10. Cofactor also equal to minus 10 because 1 plus 3 is even. Now A21. What about A21? A21. Minor of 2 is minus 4 plus 9. Minus 4 plus 9 is 5. Cofactor equal to minus 5 at right. Then A22. Minor and cofactor are same. Minor of 1, 6 minus 12. That is minus 6. Cofactor also minus 6. Then A23 equal to cofactor of minus 1. So minor of minus 1 is minus 9 plus 8. That is minus 1. Cofactor equal to plus 1. Then last one A31. Minor of 4 is 2 minus 3 minus 1. Cofactor also minus 1. Then A32. Minor of minus 3 is minus 3 minus 6. That is minus 9. Cofactor equal to plus 9. Then last one A33. What about A33? Minor of 2. 3 plus 4, 7. Cofactor also 7. Now by using these cofactors, you can write adjoint directly without writing cofactor matrix. What is adjoint of A? Adjoint of A, that is transpose of cofactor matrix. First row elements minus 1, minus 8, minus 10. You have to convert to first column. Minus 1, minus 8, minus 10. That means without writing cofactor matrix, we can write adjoint directly. Second row changes to second column. Here second row is minus 5, minus 6, 1. So second column will be minus 5, minus 6, 1. And third row changes to third column. Minus 1, 9, 7. Okay. Now this value you can substitute in this equation. So x will be minus 1 by 17 into A inverse, that is minus 1, minus 5, minus 1, minus 8, minus 6, 9, minus 10, 1, 7 into matrix B. What is B? 8, 1, 4. Now you have to multiply these two matrices. So I get x equal to minus 1 by 17 into minus 8, first row and first column, minus 8, minus 5, minus 4. Okay. Then A21 will be minus 64, then minus 6 plus 36, 9 into 4, 36. And A31 minus 80, then plus 1, then 28. Now we can simplify this one. So what about capital X? That is matrix X, Y, Z is equal to minus 1 by 17 into, we have to add these three terms, minus 13 minus 4, that is minus 17, minus 70 plus 36 equal to minus 34, then minus 80 plus 29, that is minus 51. Now we can multiply with this minus 1 by 17. You will get 1, 2, 3. So now you can equate both sides. So answers are x equal to 1, y equal to 2 and z equal to 3. So this type of questions are very important. Okay. And the question, solve x plus y plus z equal to 6, y plus 3z equal to 11, x plus z equal to 2y. Here some variables are on the right hand side. So we can rewrite the question. So we can write question as x plus y plus z equal to 6. Then this one is 0x. Y plus 3z equal to 11. And third equation is x minus 2y plus z equal to 0. Now same procedure you have to follow. Matrix equation of given system is 1, 1, 1. That is coefficient of x, y, z. And second row 0, 1, 3. And third row will be 1 minus 2, 1 into matrix x, y, z equal to constants 6, 11, 0. This is of the form ax equal to b. So first you have to find determinant of a. Determinant of a is equal to, we can find along first row, 1 into 1 plus 6, that is 7. Okay, then minus 1 into 0 minus 3 plus 1 into 0 minus 1 is equal to 7 plus 3 minus 1 equal to 9. Okay, 9 is not equal to 0. Therefore, system is having unique solution x equal to a inverse into b. Actually, we are multiplying both sides with a inverse. After that, we are getting x equal to a inverse into b. That's a you need not write. Since determinant of a not equal to 0, we can say that system is having unique solution x equal to a inverse into b. If determinant of a equal to 0, then you have to go for another method that I will explain in the next class. Okay. Now we can find cofactors. So a11, that is a11, 1 plus 6 is equal to 7, and a12 equal to minor of 1 is 0 minus 3, cofactor equal to plus 3 because 1 plus 2 equal to odd. Now a13 is cofactor 1, minor of 1 is minus 1, cofactor also minus 1. Now a21, minor of 0 is 1 plus 2, that is 3, cofactor equal to minus 3. Now a22, minor of 1 is 1 minus 1, 0, cofactor minus of 0 is 0. A23, minor of this 3 is minus 2 minus 1, that is minus 3, cofactor equal to plus 3. Okay, now last row elements, A31, minor of 1 is 3 minus 1, 2, cofactor also 2, then A32, minor of minus 2, that is 3 minus 0, 3, cofactor equal to minus 3 because 2 plus 3 odd. Last element A33, minor of 1 is 1, cofactor also 1. Okay, after this step we can write adjoint directly without writing cofactor matrix. So adjoint of A. What is adjoint of A? First row you have to write as first column element 7, 3, minus 1. and second row changes to second column, -3, 0, 3, and third row changes to third column. So 2, -3, 1. This is adjoined. Now we can substitute these values in this equation. X equal to A inverse into B. So what about X? X equal to A inverse, that is 1 by determinant of A, that is 9, into adjoined. Adjoined is 7, -3, 2, 3, 0, -3, -1, 3, 1 into constant B, that is 6, 11, 0. These two matrices you have to multiply. So you get 1 by 9 into 42, right, minus 33 plus 0. And what about A21? Second row and first column you have to multiply. You get 18 plus 0 plus 0, 18. Okay. Then A31, third row and first column, -6 plus 33 plus 0. So now we can equate both sides. What about X? X equal to matrix X, Y, Z, right, equal to 1 by 9 into matrix minus 42 plus, 42 minus 33, that is equal to plus 9, and second one is 18, and third one -6 plus 33, that is plus 27. Now we can multiply this matrix with 1 by 9. So you will get 1, 2, 3. So now we can equate both sides. So answer X equal to 1, Y 2, and Z equal to 3. I think now you understood how to solve system of equations by using matrix method, right? Dear students, this is one important topic because you may get a 6-mark question from this section. Okay. So now we can conclude this topic. In the next class, we will continue. Thank you.